So problem number 1 says to write a conjecture that describes the pattern in each sequence, then use your conjecture to find the next term in the sequence. All right, so let's look at part A. To go from 1 to 3, and then from 3 to 5, and then from 5 to 7, what's happening each time? They're adding 2. So my conjecture then would be each term in the sequence is 2 more than the previous term. Each term in the sequence is 2 more than the previous term. So what would the next term be? 13. The next term is 13. Perfect. Let's go look at part B. To go from 2 to 4, that's adding 2 again, right? But do you add 2 to go from 4 to 8? Times 2. This is multiply by 2 each time. And so my conjecture would be each term in the sequence is double the previous term. Each term in the sequence is double the previous term. So what's the next term? 64. The next term is 64. Writing conjectures is simply finding a way to verbally describe the pattern that you found so that you can use that pattern to continue this pattern on more and more and more. What else would you guys like to see? Number 2, let's do it. Number 2, write a conjecture to find the 5th term in the sequence. 60, 53, 46, 39. What is happening each time? 7 less, yes. Each term is 7 less than the previous term. Each term in the sequence is 7 less than the previous term.
Good morning.
Morning.
How are you?
I'm doing well. Thank you much.
That's good. You have a nice day.
Thank you.
Hey, Jamal.
Each term in the sequence is 7 less than the previous term. I love it. Number 7? Absolutely we can. Are we done with number 2 before we go to number 7? Yes. They did not ask us to find the next term in the sequence, so we can stop there. Could you find the next term in the sequence?
We said it. 32.
No, you would not get a point off because what you said was correct. Even though it didn't ask for it, if you say a correct thing, you do not get points off for it. 32 is absolutely correct. Number 7. Number 7 says write 3 true statements from the picture below. Write 3 true statements from the picture below. So let's start with, what do these markings mean? Yep, this is number 7. I'm sorry, I did not hear. What do the markings mean? Congruent. So one thing that I could say is that segment AB is congruent to segment BC. If 2 segments are congruent, what does that mean about their measurements? They're equal, they're the same. So I could make another statement here where I didn't say the segment AB, I could say the length of segment AB is equal to the length of segment BC. That's another true statement that I can write about the picture. All right. Not a trick question, but almost. How many segments are in the picture? 3. What types of segments do we have? In this picture, I've got these 2 right here. Would I describe those as little segments or big segments? Those are little segments. And we take the 2 little segments, put them together, and it gives us the big segment. That's my segment addition postulate. So that's something else that I could say about this. I could say that the length of segment AB plus the length of segment BC is equal to the length of segment AC. I know it said write 3 true statements, but I'm going to write just a couple more. Is that okay? Other things that we want to be able to recognize here. If AB and BC are the same size, and I only knew the size of AB, let's pretend this is 5. How big would the whole thing be if one of the little ones is 5? 10. What did you just do in your head? Addition. Or you could do what? If we have 2 things the same size, you can either add it to itself, or what else could you do? Not square, but you're close. Multiply by 2. Squaring would be multiplying by itself, so that would be a 25 instead of a 10. Yes? Yes, we can write B as the midpoint. B is the midpoint. All right, here's the statement that I was trying to get to. If I know how big AB is, I can take that and double it, times it by 2, and that gives me the length of the whole thing. Would this still be true if I put BC in here? Yes, because BC and AB are the same size. So I could do 2 times AB or 2 times BC. What about this? What about if I didn't know the size of either one of the little ones, but I knew the whole big long segment was 30? What could I do to find one of the little ones? Divide by 2. So there's another statement that I could make. I can say half of the big segment, half of AC, equals AB, or equals BC. It equals either one of the little ones. All right. We've doubled what they've asked for. Yes. Yeah, go ahead and go. Yep. Huh? I believe you're supposed to go down now. Do you know where you're supposed to go? Okay, so do you know where student services is? You know where guidance is? Do you know where the nurse's office is? Okay, so other side of the hall from the nurse's office before you get to those doors. If you look at the answer key that I have posted in Canvas, where is the answer key in Canvas? Modules, go to the Canvas page for today. Where will you find it on that page? All right, let's go there real quick. All right, so here's the Canvas page. You go to modules if you're just on the regular page. Make sure you're under module 3A. Scroll towards the bottom. You want today, Tuesday, 9/16. If you click on that and you scroll to the very bottom of the page, Right down here at the bottom, in bold, is where the answer key is.
See, I said PDF. You said PDF.
So if you look at this, here's number 7 on the review key. I came up with 10 different things that I could say. I'm going to stop at 6 for our example, but there are more things that I can say. Notice these two are almost exactly the same, except this one says AB and this one says BC, because those are both the same size. Same thing here. AC is equal to 2AB, AC is equal to 2BC. So those are 2 true statements that I can make. What else would you guys like to see? 8.
I have a question about that.
Yes. What's your question?
So when we do the explanation, like even if we do it true, we have to explain why it's true on the test.
Yes. So when something is true, you have to explain why it's true. If it's false, you have to provide a counterexample, which most of the time should be a drawing. Most of the time should be a drawing. Number 5. If 2 lines are perpendicular, then they intersect to form right angles. Identify the following statements as the contrapositive, the converse, or the inverse. So let's go through and write down what we remember about these. So the converse, this is the one that we learned first. What do you do to a statement to make it the converse? Yep, we're going to switch. Inverse was the next one that we learned about. What do you do for inverse? Not with the hypothesis, not with the conclusion. And then what about the contrapositive? Not switch. You guys remembered that really well. Not switch. Barely enough room to write that. All right. So my original statement, if 2 lines are perpendicular, then they intersect to form right angles. Let's find the one where they just switch that. So it doesn't have any knots in it. It's just switched. C. C would be my converse then. And this is the way I would do it on the test too. Instead of reading the statement and trying to figure out which one it is, I would decide which one I'm going to go and find. I would read my sentence, figure out what the converse is, and go find the one that's the converse, and then write down converse. For the inverse is not, but we don't do any switching. You said that's B? If 2 lines are perpendicular, so if 2 lines are not perpendicular, absolutely. Not perpendicular, not form a right angle. This is our inverse. One of the other things that I would recommend doing on the test also, either up at the top of the page when you first get your test, or when you get to a question like this, I would absolutely have this written down. That converse is switch, inverse is not, contrapositive is both. I would write that down on my paper so that when I get to those questions, I'm not like racking my brain trying to remember. So process of elimination means that A is which one? Contrapositive. If 2 lines do not intersect to form right angles, then they are not perpendicular. You said 6? Absolutely. That is our contrapositive. Number 6 next. That'll finish out this page. Yes. Yes. All right. Number 6. Write name, date, and time on there for me. So we have our original conditional statement. If 2 angles are a linear pair, then they are supplementary. Before we even start writing the converse, is this original statement true or false? If 2 angles form a linear pair, or if 2 angles are a linear pair, then they are supplementary. That is true, yes. Remember, a linear pair would look something like this. We have side-by-side angles. that together make a straight line. A straight line is 180 degrees, and so that's why they are supplementary. All right, then we go to write our converse, which is the one where we switch. One of the things to remember when you do this switch, if there's any pronouns at the end of the sentence that's going to be switched to the beginning, I want to take out the pronoun and replace it with what it's actually standing for. Are there any pronouns in the back half of the sentence? Yes, what is it? They. What do we mean by they? The two angles. So instead of if two angles are a linear pair, we're going to say if what? I don't want they at the beginning of my sentence. What does the they stand for again? Two angles. So I would say if two angles are supplementary. I don't want the pronouns at the beginning. I can reuse the pronouns at the end of the sentence, but I don't want pronouns at the beginning of the sentence. So if two angles are supplementary, then what? Then they are a linear pair. Here we can use a pronoun again. We don't have to say then two angles. So then they are a linear pair. True or false? If two angles are supplementary, what does supplementary mean? Add to 180. If two angles add up to 180, then they are a linear pair. Linear pair angles have to touch, like these two. Do two angles that add up to 180 have to touch? No. They do not have to touch. So this would be a false statement. I would absolutely draw a picture in this circumstance. So I want two angles that are supplementary. I need them to add up to 180, but I don't want them to be a linear pair. Thank you, Gil. So I don't want them to touch. So I'm going to draw two angles that don't touch each other. Something like, I don't know, this and this. Are those two angles a linear pair? Nope, don't touch, not a linear pair. But I need to make sure that they are supplementary. And you said supplementary means what? Adds to 180. Give me two numbers that add to 180. 180. I like it. So this angle over here is going to be my 100-degree angle, and this angle over here is going to be my 80-degree angle. They are supplementary, so the first part of the sentence is true, but they are not a linear pair. That makes the whole thing false. So far, so good? All right. Let's do part B now. All right, let's do part B. Inverse. What do we do for inverse again? Not. Inverse is not. We leave everything in the same order, but we put not with the hypothesis and not with the conclusion. So what's this going to sound like? That's perfect. If two angles are not a linear pair, then they are not supplementary. here's the thing about when we do converse, inverse, and contrapositive. The converse and the inverse will always have the same truth value. So this one would have to be false because we said the converse was false. When you're doing the test tomorrow, your converse and inverse should have the same truth value. Don't mark one as true and the other as false. Converse and inverse have the same truth value. And I can reuse the exact same counterexample. I want to draw two angles that are not a linear pair, but that really are supplementary. So I can reuse my 100-degree angle and my 80-degree angle for this counterexample. Counterexamples, if possible, should be drawn. Because when we write it out in words, we tend to explain a concept rather than give an example. Let me tell you the difference between these two things. When my daughter was very little and in preschool, she was learning about her shapes. And I taught her what an octagon was. I said an octagon is a shape that has 8 sides, which is true. But that didn't help her picture it in her head to understand what an octagon was. So then we were out on a walk, and I pointed to a stop sign. And I said, that's an octagon. And we counted the sides. I want something that I can point to and say that right there is why this is false. So if possible, draw a picture for your counterexample. If it's not possible, make sure you're giving an example and not an explanation. All right, let's do part C. What do we do for contrapositive? Yep, switch and not, or not and switch. I don't care which way you do it. Not, and switch. So what would this sound like then? That was absolutely perfect, and thank you for replacing that pronoun with what we were talking about at the beginning of the sentence. If two angles are not supplementary, thank you. Then they are not a linear pair. So just like the inverse and the converse have the same truth value, the contrapositive and the original conditional statement will have the same truth value. This original conditional statement, if two angles are a linear pair, then they are supplementary. Did we say that was true or false, the original one?
True.
That's true. So this one would have to be true. If it's true, we don't give a counterexample, but we do give an explanation. So this says if two angles are not supplementary. Well, supplementary means they add up to how much? 180. How many degrees is a whole line? 180. So if they don't add up to 180, can they make a straight line? No. So for my explanation here, I would say a line is 180 degrees if two angles don't add to 180, they can't make a line. Which is what a linear pair does. A linear pair makes a line. What else would you guys like to look at? Which one? Number 9, absolutely. Number 9. While we're here, you okay if we do 8? If we did 5, 6, 7, then we can do 8, 9, and 10 even, since they're all on the same screen. These are really fast ones. We are giving reasons here. So stuff that comes off the red paper for tomorrow on the test. You do not get to use the red paper. But for proofs, you will have a word bank. So you will still get prompted with what some of the ideas are that you would want to put in there. It also narrows it down. It's not everything that's on the front and the back side of the red paper. So it'll actually be faster to have the word bank versus the red paper. For problems like this, you'll either have a word bank or you'll have a matching thing or something so that you have, again, prompts on what these properties are called. What are they showing us right here? What do we call that object? A line segment. What are they doing in this equation? Addition. Addition of what? What is Ki? Yep, Ki is a segment. What is Ia? A segment. They added those segments together to get Ka. What is Ka? Another segment. Which one's the big one? Ka. So they added 2 small segments together to get a big segment. Does anybody remember what we call that? That's exactly correct. This is the segment addition postulate. All right, now to the actual question, number 9. What is this a picture of? Yeah, well, we've got all kinds of angles in the picture, right? We have vertical angles, we have linear pairs, we have all kinds of angles. But over here, when they're talking about the angles, they're talking about which ones? The vertical angles. 1 and 3 are vertical angles. They're on opposite sides of the x. 2 and 4 are vertical angles, opposite sides of the x. So if I look at a picture and I see vertical angles, why am I allowed to come over here and say those vertical angles have the same measurements? Why are we allowed to say the vertical angles have the same measurements? What kind of angles are they again? Close. Definition of vertical angles lets me look at a picture and say, these are vertical angles, and then stop there. Vertical angle theorem, so very closely related. The definition just lets me say, there it is. The theorem lets me talk about their relationship to each other, that they're congruent or that they add to 180. Vertical angle theorem. While we're here, let's go ahead and do number 10. Number 10 says, if angle P and angle Q are supplementary, then angle P plus angle Q equals 180. If I know they're supplementary, why am I allowed to say that means they add to 180? Definition of supplementary angles. Beautiful. Would you guys like to see something else, or do you want to keep doing problems like this? Something else. I won't go to a different one yet. What else would you like to see? 13, and did you have one, Rain? 11. All right, we'll do 11 and then we'll do 13, since that's the way we'll see them as we go through the packet. 11 and 13.
8 through 20.
8 through 20, well, 8 through 19 is just reasons that we would use in proofs. It's just like this. You're just going to write down the reason.
Can we do 22?
Yep. So we're going to do 11, 13, and then we'll go to 22.
No, like 20.
Oh, 20 as well. Yes, I can do that. While we're here, are you guys okay if we just slip in number 12? This is real fast. Number 11. If segment AB is congruent to segment CD, then segment CD is congruent to AB. So this one was on the right, correct? And then it moved to be on the left. AB was on the left, and it switched to be on the right. What property doesn't let me really make any changes, only a flip? Symmetric property. That's our symmetric property. I love number 12. Love number 12 while we're here. Look at this big long equation here as part of my if. And then look at this big long equation back here as part of the then. What changed? Which angle? Measure 3. What is it over here? 4. Other than that, everything else stayed the same, right? And we're told right here that 3 and 4 are the same size. Why am I allowed to take one thing out of an equation and replace it with something that's the same size? Substitution. That's my substitution property. All right, number 13. What do we have in this picture? What's it showing me here? What do we call this object? An angle. How many angles are in the picture? Careful. 3. What are they doing here? Adding. What are they adding? What is this? Angle. Angle SIK and angle KIT. So they're taking an angle plus an angle. And what do they get when they add angle plus angle? A bigger angle. Why am I allowed to take 2 little angles, add them together, and get a bigger angle? Yes. Angle addition postulate. Fantastic. All right, let's go do number 20 now. Number 20 is the first proof in the packet. And we got to do the whole thing. Number 20. They didn't give us a single statement or reason to work with here. But I know what the first statement should be. So I can fill that in right now. What should my first statement be? Perfect. Thank you, Aiden. Segment GH is congruent to segment JK. Why am I allowed to make that statement? Because it's the given. Am I ever allowed to use prove or proven as a reason? No. Proving is what we're doing. I won't know this last reason until I know the statement that comes before my last statement, because I have to see what changes, what's different. Speaking of the last statement, what will the last statement be? X equals 58. That comes down here. All right. We've got 3 statements to fill in and 4 reasons to give. One of the things that I notice, guys, put things away unless it's the review, please. One of the things I notice, my given has a congruence symbol. But where I'm trying to get to doesn't have congruence. It has an equal sign. So I want to make this an equal sign somewhere in here. Can I say that these two are equal? Yes. So I can write down without the bar over the top, because it means the length of segment GH is equal to the length of segment JK. What's that bar over GH mean? Segment. Bar over JK also means segment. What relationship do these two segments have to each other? They are equal, but they are congruent. They are the same size. If I know something is congruent, why am I allowed to say it has the same measurements? Definition of congruent segments. All right. Something else I notice about where I'm trying to get to at the end is it has an X in it and it has a number in it. This doesn't have any X's or numbers. Where should I go look for X's and numbers in the picture? How big is GH? 7x minus 32. I just made a replacement. What property did I just use? Substitution, yes. How big is JK? 6x plus 26. I just made another replacement, so I did substitution 2 times. This is my substitution property. One more statement. What's the next thing I would want to do if I'm trying to solve this for x? What would your next step be? Subtract 6x from both sides. What would I get if I subtract 6x from both sides? So I'd have x minus 32 equals 26. What did we just do to both sides? So what property did we just use? Subtraction property of equality. What happened to get from this statement here in orange to what I'm trying to prove? What changed? Plus 32 on both sides. What property is that then? Addition property of equality. Addition property of equality. Fantastic. We've got 4 minutes left, which is enough time for a very short one if you still want to see something. 21. Let's see if I got time for it.
No, we need to do 24.
No, we need to do 21. Aiden asking about the
We actually haven't done one like this. Let's see if I have enough time. It says the measure of angle LKJ, that's this whole thing right here, is 137 degrees. PKJ is this guy right here, is x plus 5 degrees. And LKP is x plus 90 degrees. Find the value of x and the measure of angle LKP. What postulate, theorem, property are we going to need to use here? How many angles are in the picture? 3. What kinds of angles do we have? I have 3 angles in the picture. I have this one and this one. Those are little or big? Little. And then this angle here. That one is little or big? Big. What can I do when I have 2 little angles that make a big angle? Add them together. That is the angle addition postulate. So we're going to add the little angles together. So that would be the measurement of angle PKJ plus the measurement of angle LKP equals my big angle, LKJ. So then I'm going to substitute in x plus 5 in the place of PKJ. I'm going to substitute in x plus 90 for LKP. And I'm going to substitute in 137 for LKJ. We have to combine like terms first. My x's combine. and my constants combine. What do I get when I combine those? 2x plus 95 equals 137. Then we minus 95 from both sides. So that would give me 2x equals what? What is 137 minus 95? 42. Then we divide both sides by 2. What is 42 cut in half? 21. X is 21. And then we want to find LKP. Measurement of angle LKP is x plus 90. So I have the measurement of angle LKP equals 21 plus 90. What is 21 plus 90? 111. So 111 degrees for LKP. Answer key is posted on Canvas. We already looked at exactly where that is. You'll be turning in this review tomorrow when you come in for the test. Please send me any questions you guys have this evening if you get stuck on anything on the review and you can't figure it out from the key.